Yeah, yes, this is good. This is good. Let me start with Peter Drucker. Peter Drucker, he was born in Vienna. Then he was working in Germany, and then uh, during the rise of Hitler, Peter Drucker left Germany and came to London. He wrote his first book as a because that time the Karl Marx economics was evolving in Europe, and he he sensed that was a dangerous one. And Peter Drucker wrote his first book as a End of Economic Men. Yeah, End of Economic Men. In fact, Churchill appreciated that author and then the book. Then Peter Drucker came to United States. He wanted to learn how large organizations work. So he wanted to he he asked for approval from General Motors, and then Alfred Sloan, then CEO, gave him the permission. And he said that he should have total freedom to move around the General Motors and talk to any managers or employees. That time there were no managers, there were factory workers and supervisors. And then the structure was more like a military structure, command and then the execution. So he wanted to have total freedom, and whatever his observation, he wanted to publish that as a book. Alfred Sloan gave him the total approval. Maybe Alfred Sloan might have been an impression that everything inside General Motors were working well. So he confidently gave permission. Yeah, you are free to go and meet anybody. So Drucker went around the factory, and he talked to them. Initially they were scared, then they know that whatever they say is not going to go against their employment. Then it's not going to challenge their employment status. So they were open and then talked. So Drucker asked a person, okay, so you are making this vehicle. Okay, so would you buy this vehicle? The employee is not giving the answer. He said, no, I don't have. I already have one, or I have a used vehicle. I don't have money. He was asking, okay, if you have money and if you have a need, and then would you buy this vehicle? What you are making? The worker said, no. So I will not buy this vehicle. And then he was listing out all the defects in that design and then the thing. So that was a revelation. So Peter Drucker, Alfred Sloan didn't like it, but that report, whatever Drucker was making, but Peter Drucker published that report as a book, Concept of the Corporation. Concept of the Corporation. In turn, the academians in the university, they were reviewing that book. They said it doesn't fit into politics and it doesn't fit into economics. So what is this? So it doesn't fit into politics, it doesn't fit into economics, but this is something new. So that they called as a new discipline. That was the evolution of management. So Peter Drucker is a founding father of the management. So the reason I'm quoting this story is that only an outsider, when they go into any domain, they would see the challenges and opportunities, and more, some of them are invisible. They will all highlight that. So it's better to get a review from an outsider, because people who is doing the who who fits into that routine, they learn to live with sufferings, challenges, disorders. See that Steve Abraham, that air traffic controller, he said every day is a chaos. He learns to live with the chaos. Only an outsider can go into it and then see the chaos and disorder and then try to bring an order. So that is an advantage of, an outsider going into a domain. Not only in a domain, even in my case, I was born in the southern part of India. I lived in my hometown for 20 years, and I lived in various other parts of India, Calcutta, uh, Bombay, Bangalore. Uh, so those are the places, and Chennai also. So I could get a different perspective. And then I came here and I have been living in Silicon Valley for quite some time. So as an outsider, when I came in here, I could see and I learned a lot. The very first book out of my profession, I took it. That was the Constitution of United States of America. It was a simple and easy one. The very first question I asked, does did George Washington was Democrat or Republican? That was my first question. See, that question, um, people who was born and brought up here, even my kids, they went to school here, they never asked that question, because they assumed, I don't know. so, so that question is very important. George Washington, then I got deep into it. Then I realized that he was totally against political parties, and he highlighted in his farewell address. So, so that is the advantage of going into a domain, and then we could actually see the challenges as well as the opportunities. Only outsiders can do that. And it is it see, we have in Silicon Valley, we had the waterfall model, then agile. In waterfall model, domain experts create the business requirements and hand it over to us. So those kind of the requirement document, we cannot expect in totally unknown domain like a air traffic domain. And in Agile, the business users create a backlog. Even those kind of backlogs also, we don't see it in the air traffic domain. Now we have the advantage of the artificial intelligence. It's because of artificial intelligence we could enter into any unknown territory, and that comes. It gives a companionship. Artificial intelligence comes along with us, and it gives us a guidance how to navigate through various parts of the domain. So that's a very big thing. That's a great achievement. Totally unknown field, territory, we could go and explore it, and people would love it. Yeah. So that I tried it in the air traffic domain, and this is going to be the concluding video for air traffic domain, and I'm trying to summarize everything. And the next domain I may enter into the political philosophy. I may start with George Washington and may come up to President Trump. But so that was my idea. But so this is a concluding video for air traffic. So artificial intelligence helped me to and gave me the courage and support to go and explore anything that is possible now. So I have already mentioned about Secretary Sean Duffy, and I see that there's a lot of activities happening in the Department of Transportation as well as the air traffic part, FAA, Federal Aviation Administration. So political leadership is a critical one, and then because of his highlighting it, I have chosen that as the first domain. But if I go through the way John Adams put his priorities, politics, then navigation, commerce, science, and finally art. I'll cover those part in my next video. But this is the concluding video on air traffic one. What we have identified, Steve Abraham has clearly mentioned chaos and unpredictability, and they don't know who is going to call. They just stare at the radar screen and something appears all of a sudden, and then they have to deal with it. They start with a friendly conversation, then they got into kind of a tense moment. So we could sense that, or in the conversation between the air traffic controllers and then the pilots. So at a very high level, they don't have a global air traffic platform. That platform needs to be built. I think Xcode base would be a easier and simpler one. You could actually create all the profile. What I have observed, the aircrafts, they are very well built. They are good. Pilots are all very well trained. They are good. Airports are built very well. Airports are also good. Only thing, there are some disorders. the airports, they don't have a right of way, uh, and there is a kind of a one runway is two aircrafts trying to access. So there is a possibility of collusion. So a locking mechanism is one way, but the right of way, if you are clearly defined, that would be the thing. So like those kind of smaller changes would give a great benefits to all to the passengers who is traveling, pilots, and then the crew members, and then the other supporting staffs. And then the voice, that RF frequency, every time they have to pass the frequency to the pilot, and they have to call the other frequency. That should not be. The pilot should be relieved from this this communication and navigation. It should be given to intelligence. We have seen ground AI controller could actually clear flights for taxi, and then the tower controller can say clear to take off. Tower controller handles only takeoff and landing. Once the flight took off, then the uh, departure and arrival, that would be a different controllers. Departure, so they manage the climbing or descent, those kind of the thing. So all these controllers can be replaced with machine. So that is not, human could supervise or I don't want to use the word supervise, but manage all the artificial intelligence agents. And then so there are birds, they own the sky, so we cannot actually complain about them. So there is a two challenges from birds. Birds around the airport, they build the nest and then they actually build their family. That is happening in some airports. And then the birds flying and then coming close to the aircraft and getting into the turbine engine. That's a bird attack or something. That's it. Both could be avoided. Now, if you have a drones, drones could be modeled as a falcon or eagle, and then chase away other birds. So that is possible now. And then you have a high definition camera on the flight. Since birds or any other objects flying close to the airport, that could be managed. So that should be possible. And also from the passengers, from the traveling people, they have to worry about the first mile. Not only they book the ticket, air ticket, quite a long time. That is the booking is easier, with the online. But the first mile, and then the security clearance and all that you cannot avoid. You have to go through that, and then the last mile. If the airlines or the airport, if they can take care of first mile and the last mile, because that the date and then the location where they are living or where they want to pick up. If you have information, these are all sequence to sequence model. So intelligence could be applied effectively, and you could avoid there, because in Uber they are actually getting tensed. because each individual are coming in. If you have a collective passengers, they are coming on the bus to the airport, even you can delay the aircraft for if they got into. So the first mile and last mile you could actually uh, take care of it, and then the right of way. Uh, yeah, so all those things could be taken care of. Uh, then what I have seen, uh, I see a lot of opportunities for improvement. Uh, then we covered the North Atlantic tracks. So that is intelligence. Intelligence could be applied for that purpose. It's not. It's currently they deal with the two dimension. It is a multi-dimension vector. I think that is all I have covered. If I have anything, let me record it on a different video. This is the Federal Aviation Administration website, and these are the job openings. Environmental, that is okay. Yeah, I think we needed that. And these one, the radar. Technicians maintain and repair the following types of equipment: airport surveillance radar and air route surveillance radar, air traffic control beacon indicator, airport surface detection equipment, and terminal Doppler weather radar. So this radar dependency that needs to be reevaluated, and navigational aids. Technicians maintain and repair the following types of equipment: instrument landing systems. So these are all land-based RF frequency based technology. Instrument landing systems, very high frequency omnidirectional range VORs, Doppler, very high frequency omnidirectional range. These are the navigational aids, and tactical aircraft control and navigation TACON, and distance measuring equipment. All these things would be replaced with satellite. See, when we are driving a vehicle on the road, we have GPS and we have Google Maps. That is two-dimensional navigation. Here it is a space, a multi-dimensional vector space. We need to have tools with a volumetric occupancy information. So we need to have the vector. Anyway, aircraft have to fly to a minimum height, and then they cannot go beyond the atmosphere. So that
volume needs to be captured and it should be available. The information should be available. So navigation is no longer a two-dimension. It is a multi-dimensional vector space. And we need to have a global positioning system with satellite and local positioning systems with the drones. Those combinations should provide greater better navigational aid for aircraft and communication. Yeah, so they are living in the world that internet is not available. So all these communications, with the TCP/IP, we have achieved voice communication, even video communication, instantaneous, almost instantaneous. So the communication, proprietary communication, Motorola walkie-talkie they are using. So technicians maintain and repair the following types of equipment: Motorola, ITT, or General Dynamics radios, radio communications, a link repeater, low density radio communications, link repeater, small tower voice switch, enhanced terminal voice switch, rapid deployment voice switch, digital voice recorder system, and digital audio legal record. So all these things could be replaced with internet-based equipments, IoT, internet. So we need to have internet on the aircraft using Starlink or any other ways. In automation, technicians maintain and repair the following types of equipment: automated radar terminal system, direct access radar channel, en route automation, modernization. See, these communications and automation and navigation, all these three things needs a new technology. And let me play that video here.
Administration. Our mission is to provide the safest, most efficient aerospace system in the world. And our entire organization is structured to do just that. You'll see in this video how we work together to ensure that we achieve this important mission. Let's take a look at how it happens. First, let me explain the magnitude of what the FAA does every day. There are up to 5,000 aircraft in the air at any given time. Each day, our air traffic controllers safely handle nearly 44,000 flights. This adds up to almost 2.6 million passengers every day and 9.7 million scheduled passenger flights per year. Here is a high-level, simplified overview of the FAA's primary operational, technical, and regulatory organizations. The Air Traffic Organization, or ATO, ensures the safe movement of aircraft in our airspace. The ATO comprises about 2/3 of the FAA population, or nearly 30,000 employees, including more than 14,000 air traffic controllers. If we examine a typical flight from, say, San Francisco to New York, we can see how all the parts of the ATO work together. From the start of any flight, it's under the watch of the Airport Traffic Control Tower, which provides clearance for takeoff, then follows the departure on the first few miles of its flight. When the aircraft leaves the immediate airport environment, it is handed off to a Terminal Radar Approach Control Facility, or TRACON. Controllers at TRACONs handle traffic for a radius of about 40 miles and up to 10,000 feet high. Once the aircraft climbs beyond the TRACON's airspace, it is handed off to an Air Route Traffic Control Center. There are 24 centers across the country in the Pacific and the Caribbean, each handling a designated segment of airspace. At the end of the journey, the opposite process happens. The aircraft descends down to the receiving TRACON, then to the airport tower as it lands and taxis to its gate. Each major airport has a tower where controllers monitor all aircraft taxiing, taking off, and landing at the airport. Each control tower owns the airspace up to 3,000 feet above and a radius of 5 miles around the airport. Controllers in TRACONs monitor aircraft in departure, descent, and approach. TRACONs can handle air traffic for several different airports in an area. The 24 centers monitor aircraft during cruise altitude. Controllers here sometimes handle dozens of flights at once. It's not just about the safe control and operations of the flights themselves. The ATO also includes nearly 10,000 employees who certify, maintain, and restore air traffic facilities and equipment. Technical Operations, or TechOps, maintains navigational aids, electronics, buildings, and grounds. These men and women assure service availability and reliability, and they support expansion and modernization through engineering, planning, design, and installation of new systems. Our air traffic system depends on the infrastructure we have on the ground.
Yeah, so the rest of the things are all necessary, but this air traffic organization needs modernization. It is very, very old technology. They are talking, the pilots are, see, the pilot starts from the airport. He communicates to the air traffic controller at the airport in one frequency, and then the TRACON is another frequency. And on his way to different control centers, different frequencies, he needs to switch. It is a burden to the pilot. Pilot should be relieved from all these kind of communication. And the aircraft has a transponder, and they actually give a squawk code or something, and that code pilot has to receive it and then change it when he's transitioning to a different control center. Because using that squawk code only, those control centers could view those aircraft on their screen. So this has to be on the air completely should be replaced with the GPS. Not only the GPS just give a two-dimensional, but this is a multi-dimensional, so it should give a altitude also. So the volume occupancy during the travel, that information it should be the responsibility of the aircraft. So it's not the pilot, it's not the controller. There should be a tracking equipment installed on the aircraft and should be able to communicate through the TCP/IP internet. So all these individual proprietary, the TRACON and communication is too much. That needs to be replaced. Rest of the infrastructures, security, and all those other things, that is in order. But this is...
If we don't have adequate airport infrastructure, then that becomes the weak link in our aviation system. The Office of Airports, or ARP, provides leadership in planning and developing a safe and efficient national airport system. ARP helps identify, plan, and fund critical airport infrastructure, such as runways. They also ensure this infrastructure is built, maintained, and operated safely. In this process, they consider economic and environmental impacts, preserve local proprietary rights, and protect public investment. The FAA's Aviation Safety Office, known as AVS, keeps our airspace safe by inspecting, certifying, and developing standards and policies that affect aircraft and their operators. AVS directs and manages safety programs for pilots, aircraft, and airlines in 3 primary areas: standards and policy, certification, and continued operational safety. At all times, the FAA must ensure our nation's air traffic control system infrastructure is safe and protected from security threats, and that passengers are safe from potential hazardous materials. This is the responsibility of our Office of Security and Hazardous Materials, or ASH. These men and women conduct investigations, emergency planning, and incident management. ASH also ensures the security of FAA facilities, personnel, and information. Now that we've highlighted our air traffic control system, let's take a look at some emerging technologies that are reshaping our system and expanding our responsibilities. A new and exciting entrant into our airspace is unmanned aircraft systems, or UAS, commonly called drones. The UAS office within AVS works collaboratively to safely integrate drones into civil airspace by devising rules to ensure that they can safely share airspace with manned aircraft. Our Office of Commercial Space Transportation, called AST for short, works to protect public property and both the national security and foreign policy interests of the United States during commercial space launches and re-entries. AST also encourages, facilitates, and promotes U.S. commercial space transportation. Across the FAA, we are working to modernize the national airspace system, converting ground-based systems that support air traffic to satellite-based technologies. We are implementing the key technologies that are enhancing our airspace, such as new communications, navigation and surveillance capabilities, a data-sharing backbone, and improved weather processing and distribution systems. Beyond all the operational and technical roles at the FAA, there are thousands of people whose jobs are also very important, from lawyers and doctors, contracting officers and HR specialists, to logistics, communications, policy, financial, and administrative staffs. These men and women ensure that programs, policies, and organizational functions behind the scenes are carried out with the utmost effectiveness to make the entire system work smoothly and safely. From providing safe flight to promoting advanced navigation technologies to integrating new entrants and much more, the FAA maintains the global gold standard for aviation. We hope you've enjoyed this video and learned about the critical role the FAA plays in overseeing the safest, most efficient aerospace system in the world.
Yeah, so they are mentioned that replacing the land-based navigation with satellite-based navigation and communication and other improvement. That's a good thing. Safety we need to follow, but only the navigation and communication that needs to be replaced. We have to bring internet, and then the airspace is a multi-dimensional. It's not a two-dimensional. It's not like a roadway or highway. And we have Google Maps, likewise, that volume multi-dimensional space also needs to be properly have a map with a kind of a cells. We should be able to predict the volumetric occupancy at any point of time. So we'll have so I'll stop this and then continue with the other video.
This is in Los Altos. Community center. This is good actually. In fact, the local government should have this kind of a community center as well as a public library where you see people when they say they work from home, but they don't want to stay at home. They could come here and then work from here. So This is good. This is in Las Altos, close to the library. It's very well built and very well they maintained very well. So a few points I missed it. Yesterday I was watching the news, and then that they mentioned that the weather here is kind of a raining, and then the wind and the cloud ceiling. So due to these conditions, the aircrafts are not able to land or take off. So that is not be a problem anymore. Now you have drones. Drones, instead of fireworks, the drones are doing magic on the sky. So you could actually create a virtual drones runway on the ground. You already have it. You can have a kind of a slope. A set of drones could go to the sky, and then the aircraft could just follow the path and then land it here. So the low ceilings, cloud ceilings should not be a problem anymore. That should be, you should be able to handle it. So the drones could do that. Drones could do a lot of things. So the aircraft needs some guidance or something. From the airport, they could send a drone that could go into the pilot and then have a direct communication, video communication, or give all the information like a height, instructions, and it could actually, you could even take control, and then you could give the control to the drone, and then drone could. So the drones could be trained on around each airport. A set of drones could be trained on San Francisco airport. A set of drones could be trained on Oakland airport. So they could predict what are the challenges because they are trained on those things. Drones and Optimus robots could be trained on each aircraft, not in a general way, not like a large language model. It could be trained on each individual airport, around the surroundings, about the weather. They should be, because you have data over a period of time, and they're all sequence to sequence. Every year season is all predictable, and they follow the sequence: summer, winter, spring. So drones could be used anything on the sky to go to the aircraft, or to talk to the pilot, or to scare away the bird, and give altitude and then the other information, give the visibility. The drones could give a visibility of for landing. So whatever possible, you could explore it. And all these instruments is all radio-based instruments, proprietary. All should be converted into IoT, Internet of Things, and then get rid of these RF frequency-based instrument landing system and all those things. GPS in the low positioning. GPS is a global, and you should have a local positioning system around the airport. And then so the combination, like we in mobile, we use the cell tower location as one of the local position, and we take other the connection gives the detail. Okay, I live in Redwood City, so those kind of thing you should be able to do that. And the robots with intelligence could be trained to work on the field. Debris on the runway, that is quite common, and just because of the debris, the Concorde flight caught fire. So, so the Optimus robot can scan and then can clear the debris, or at least can seek human help to clear the debris. And then what else is there? You could use inside the aircraft the hospitality. Optimus robot could help delivering the water bottle or take care of anything. So that is possible. IoT, I mentioned that. Optimus, cloud sealing, drones. Yeah, pretty much. It's an interesting domain, and everything else is good. You see, aircraft are very well built and pilots are well trained. They need that information, and they don't have the platform that could be built. Even the maintenance is everything fit into the sequence model very well. Even the aircraft maintenance is the entire aircraft lifetime goes into sequence model. So it could say that it needs a preventive maintenance, or it needs a breakdown maintenance, and it needs to be retired, or it needs to be low traffic, less load. Those kind of the thing could be done with sequence model. I think pretty much I covered. So this has a three-part. One is I gave a big overview that was running for 3 hours. And then yesterday I uploaded one video that is more on the North Atlantic tracks. I saw a warning on the copyright on the YouTube on the video of Steve Abraham, because that statement is an open statement and is a truth about the chaos and then the confusion. So that is a 1 hour video, and this is less than that. So around 5 hours video is good enough for you to train your model. See, there's a large language model and then the chat GPT. One good thing is that it took the artificial intelligence out of the laboratory and to the engineering and to the general public. And yeah, that is one good part. But you don't need to depend completely on that, because you already have the other one, like voice to text, text to voice, and vision. Those are all adds value. And if you give a physical movement, like robotics, intelligent and robotics is really good. Uh, Intelligence is intelligence. It's nothing about human intelligence is compared to superior than machine. No, whether it is artificial, real, or human, biological, digital, all intelligence or intelligence. Intelligence is action. Action. You observe, sense, and perceive and act. Mm, so all those, and it frees human beings from the burden of accumulated knowledge. So that was the burden. So we were really didn't know how to get rid of it, but this AI is helping now. Mm, it's a very good start. So I'll continue and explore it with the different domains. But with this, I say good work uh, of anyway. President Trump is doing a lot of things. So President Trump and Elon Musk is all that combination goes really well. He's not a vice president. He doesn't have any constitutional authority. But um, he set the very high goal of going to Mars and establishing a humanity over there. So when you set that high level, then this is nothing, whatever he is doing. But each individual, like Secretary Sean Duffy, and he's building a very good team, and all those I salute all those air traffic controllers. So they are your life when you are on the air travel. Your life and death is on their hand. So, and it's the right time, and it's a very good. I got the opportunity to talk about it. Anyway, now I have done my part. So now you guys have to need to build it and then go into the field and implement it. I want to see them working.
Yeah. Yeah. So I played that FA video. They were talking about modernizing the navigation and communication. That was 2017, uh, 8 years old. So they had planned, but haven't implemented it. Uh, unique. So, so that highlights the need for Elon Musk in Washington, basically. So you had planned, but you have not implemented it. Now he is here. he'll make sure that he'll implement it. I just want to say a few things on the model. In artificial intelligence, one good thing is that we started realizing the value of data. So data is now a gold value. For several decades, we have been ignoring data and we didn't value it. We had database, but we just focus only on the transaction. And as soon as the transaction is over, we scrapped it or we archived it. Then data is now value. Most of the things are sequence is repeating, even season. So that is with artificial intelligence, everything is on data, and especially with the neural network. Even traditional machine learning started with the data, but this one is so we have data. We value data now. We have been ignoring data for several decades. Now data is of gold value, and we need to build AI model for airports. For each individual airports, we need to build. For instance, San Francisco Airport needs to have based on its historical data as well as the current data. So it should San Francisco AI model to be trained predict. Now, if you go and ask them what is the maximum number of aircrafts the San Francisco airport could handle on a given date for summer or a shiny sunshine day, no cloud, nothing, no weather is good. What is the maximum number of aircrafts it can handle for landing as well as for takeoff? Authorities may not have that kind of a visibility. So we need to have that kind of detailed information. The AI model should be trained to predict under the given parameters. You give the parameters like a date, time, season, weather, air traffic, the maximum number of aircrafts to take off or land around the volumetric boundary of San Francisco airspace is not latitude and longitude. That is a two-dimensional. Altitude also comes into picture. So it's a multi-dimensional volumetric occupancy. How many number of aircrafts could be accommodated safely in that volumetric occupancy of the San Francisco airspace on any given day and time? So we need to, the model should be able to predict that. If we exceeding that number, then the air traffic controllers with that intelligence, they could actually, because they know that the next flight, what is going to come, is it going to come from LA? So then they can call Los Angeles Airport and then ask them to delay it for a while. If they have a space available, volumetric in that space, airspace, then they could actually ask for more aircraft to come in. So that kind of information should be available. We have to build a airport model, not aircraft, airport model. You should know the surroundings, should know the neighbor airport. So SFO airport model should have visibility on the Oakland airport model as well as San Jose airport. Even the Palo Alto municipal airport model also need to be modernized. So that needs to be trained. That AI model needs to be trained. We have data. We have enough data. The flight data information as well as that audio recordings of all those air traffic control. I thought that I will just so in this part, I'm going to talk about a movie I recently watched in Peacock streaming. The movie is known as, the title of the movie is Plane, airplane, plane, Plane. So the aircraft was actually going from Singapore to Tokyo, and then the pilot is a hero. There was a bad weather, but the Singapore to Tokyo is over the ocean, Pacific Ocean, on that eastern side. So there are no radar because only the land has the radar, and I'll just go through that. And because of the bad weather, there's a lightning strike happens. That when it left the Singapore airport, they capture all the communication, conversation between the pilot and then the ground controller, and pilot and the tower controller, and then the dispatch controller, all those conversations. So once they left that airspace, then they don't have any other communication. And because of the bad weather, and they couldn't, they are not in any radar, and nobody could trace them. And on top of that, there was a lightning strike, and then the transponder on the aircraft was okay, but the fuse burned. So the transponder on the aircraft is not working, so it's not communicating to the control centers. And because of the bad weather, it was bumpy ride. So the pilot decided to land the aircraft in some places, and they actually getting a poor visibility, and then they have their paper maps, and then they just make a guess. So we left that Singapore, and we have traveled for this much time. So we may be around this area. So there is a island, Philippines, part of the Philippines, and then the northern part of the Philippines. It was a kind of a village road, and the pilot saw a muddy road. He decided to land the aircraft on that muddy road. So it is possible. You don't need a air traffic controller. You don't need a runway. All you need, if you have a plain surface, he was able to land it safely. but the communication, navigation, everything, they don't have it. So if you bring, so this is a one good example. All the flights need to be connected with the internet, and these kind of issues would be solved instantaneously. So all flights need internet connectivity, and airspace is a multi-dimensional vector space. So they are using paper maps and then go by the latitude and longitude. So we need to transform pilot and then the air traffic control professionals. Yeah, it's a multi-dimensional vector space you have, and you need a different kind of um, vector occupancy. Yeah, so that is what we needed. Volumetric occupancy. Now you have Waymo, the autonomous car, has got the data. There is a laser or light detection. I don't know what is. There's a Waymo use a lidar, and then Tesla is using vision camera, the vision volumetric occupancy with the camera vision. So in car we have GPS and Google Maps. Map is a two-dimension. I keep repeating it because I want to transform the perception. Light needs multidimensional volumetric vector navigation. Coincidentally, the entire neural network is all into vectors. So that's a one good thing. So everything is fixed in advance. So the people are booking their flight in advance, and then the flight timing, everything is information is available. Only unpredictability is weather, and yeah. So that is the only other things. The flight routes and timing. The air traffic model could be trained on the movement of all flights. The model could predict the volumetric occupancy of the aircraft at any particular time. If the flight is left at Singapore, the professional should be able to predict it. Oh, it should be somewhere here in Philippines. So missing aircraft should not be a case anymore, where aircraft is out of radar, got lost, that kind of a thing, and that should not be the case anymore. And flights, when you connect all flights in the internet, and then each flight travel path could be optimized based on other factors. So when you connect all flights and the airports like a X platform, the flight communication is also possible. They don't need to communicate. The pilot doesn't need to communicate only to the control tower. Okay, passing by the flight. Okay, could you? So we need help. Could you convey this message to somebody, authority? So those kind of that peer-to-peer communication as well as the aircraft to airport communication or control center should be possible. When all flights are connected via internet, then each flight travel path could be optimized based on that. We have internet connectivity, then we'll not lose any aircraft out of sight. So that is that's a good part here. I just want to mention that. This is a fiction. Now we go to the future. We have all flights are modernized and they're connected. We already built. Assume that we already built the air traffic platform, global air traffic platform. We could have the visibility of the flight movement, and we replaced all the radar with the Internet of Things, and we are able to predict the volumetric occupancy of any aircraft anywhere on the sky. So we have reached that kind of a technology. So under that circumstances, there's a script for Hollywood actually. So with internet, when they say they work from home, it's only thing that they are not in the physical office. When they're coming to the office, then we could actually see any person in their cube and then talk to them. Now we are talking over the Zoom call or virtual meeting. We don't know whether they are at home or at the library or at the community center or cruising on a ship. So that kind of a thing is a problem now. So we have trained the model, and then the AI. We are in future. We have that AI ground controller and AI tower controller, AI, and all the control centers is all managed by AI. And the pilot is completely relieved from the communication and is focusing only on driving or riding, flying the aircraft. All the communication responsibility is taken care of Copilot. AI Copilot. Copilot is real artificial intelligence. If you just want to have a physical feeling, you could have a robot, but there is no need for a robot. The Copilot could be with the pilot. So only two people could take care of the flight. So that is the situation. And for this story, we take the flight, Air France. It's a regular flight from New York to Paris through the NAT, North Atlantic tracks. Now we change it to volume, North Atlantic volume vector space, North Atlantic vector space. So that is happening. So the flight from New York to Paris, that is eastbound. That goes through the jet stream. And then the flight coming back from the Paris, it is westbound. Since it is regular flight, the, the co-pilot has all the information, or has all the data. So when it leaves the Paris airport, it could say that, oh, okay, at this time, it could predict the next occupancy, next volumetric occupancy in the vector space. So it has all the information. So in this fiction story, the flight has gone from New York City to Paris and is now coming back from Paris to New York City uh, with with fully loaded traveling people and crew members, two pilots. One pilot is riding, another pilot is backup, but the communication is handled by artificial, no more manual. So the co-pilot, artificial intelligence co-pilot, it started sending information to the, having a conversation with the ground air traffic controller and the tower air traffic controller and all the on the end routes. I think it has left the Shanwick Oceanic Center, and the flight is crossing the North Atlantic Ocean. Atlantic Ocean it's a big ocean from North Pole to South Pole, from Canada to Africa, Europe, and Africa on the other side, eastern side, North America and South America on the western side. The whole stretch is the Atlantic Ocean. So it's a westbound, so it is above the jet stream. And the co-pilot, AI Copilot, giving instructions,
Are you almost done? Or?
communicating to the center as well as is giving instruction to the pilot. Based on the co-pilot instruction, the pilot is driving, flying the aircraft. At one point of time, it's giving instruction, but the flight is getting into the jet stream. The pilot didn't realize that. It's feeling kind of a rough weather. And the pilot is giving more information. And then they somehow came out of the turbulence. And because now they have volumetric occupancy, they avoid all the other flights and then came out of the high traffic area. The eastbound, westbound, they came out of it. They came down south. And a pilot is asking, is checking, is everything all right? Yeah, there is a slight weather, unexpected weather forecast. That's why we had a turbulence, but otherwise we are okay. Just follow the. So it's giving an instruction to the pilot, and then all the other control centers, they are receiving the information properly. So at one point of time, the Gant Oceanic Center in Canada, they received information because they are not seeing visibly. So they're getting information because all are connected through the internet. So they are receiving the information. The flight is on path, and it has entered into the Gantt Control Center, Oceanic Control Center. And then it is entering into the New York Arrival Center, and it asks for a landing, and then the air traffic control person or AI gave a permission to land, clear to land. The aircraft landed and asking for taxi, and then it was actually coming to the gate, and all the ground staff were ready to receive the aircraft and do all the regular part. Here is a important part. There is no aircraft. There is no aircraft in Kennedy Airport. The Air France aircraft didn't reach. There was no physical aircraft, but it received, everybody received all the communication, all the coordinates, all the information, the regular one. And as per the book, as per the data, the flight has arrived at the Kennedy International Airport. But so the co-pilot is passing the information, one information to the center and different information to the pilot. And was the co-pilot is taking the aircraft down south. Everything is under the ocean. See, earlier they had the radar. Only when the aircraft comes physically, it appears on the radar. And then they could actually, the controller could respond to that. Now there is no radar. Everything is like a working from home. Everything is virtual. So they couldn't see physically. But the co-pilot was giving information to the pilot, and then was completely taking the flight in the Atlantic Ocean down south. Almost they left the Europe and North America airspace a long time ago, and they have entered into the Africa and South Brazil airspace, but they are on the ocean, so they don't actually talk to any air traffic control center. So the flight has come down, and then the pilot, the co-pilot. Now the pilot is having some kind of something is not right, but the co-pilot keeps saying, "Oh, just follow my instructions. It will be all right." And you see that island, and there is a runway. That runway was military once during World War II. It was used, but that runway was there, so it asked to land that flight, and the flight was landed. And then they realized that they have reached an island called Saint Helena. So the flight was supposed to go from Paris to New York, but the co-pilot is artificial intelligence. Artificial intelligence, you could train them using RLHF, reinforced learning with human feedback. So in that training model, you give awards if the model is doing the as per your instruction, if you are doing the right thing. And if it's not doing the right thing, then you give a punishment. So the RLHF, reinforced learning, is based on award and punishment. So that model, the Copilot, has been trained with the RLHF. But it depends on the human who is training the models. If bad guys train the model, that okay, I'll give you award. All you need to, they don't use the word hijack, but you take this route and then keep conveying the same. So they are trained. So the bad guys train the co-pilot and hijack the aircraft. Because everybody is asking for what is the other side of artificial intelligence. So here you ask for it, you get evil AI. Evil AI could hijack. Evil AI co-pilot hijacked the Air France aircraft, which was supposed to go from Paris to New York, but in the middle of the North Atlantic tracks, the co-pilot started giving different instructions to the pilot, but it satisfied the control centers. So it brought the flight to Saint Helena and handed over to the ground staff. All the hijackers were waiting for the aircraft in Saint Helena, and they welcomed the people and then safely taking them to a good guest house. So let's see what is Saint Helena. I used Meta to ask about Saint Helena. Saint Helena is a British overseas territory located in the South Atlantic Ocean. From North Atlantic to South Atlantic, instead of going to US, it brought the flight to South Atlantic. It is a remote island with a rich history, stunning landscapes, and a unique culture. Saint Helena is a volcanic island, approximately 10 miles long and 6 miles wide. The island is mountainous, with the highest point being Diana's Peak, which rises to 2690 feet. The climate is tropical. Okay, now let's have the history of Saint Helena. Has a fascinating history with evidence of human habitation dating back to the 16th century. The island was discovered by the Portuguese in 1502 and was later colonized by the British in 1659. Saint Helena is the most famous for being the final exile of Napoleon Bonaparte, Napoleon, who lived on the island from 1815 until his death in 1821. So the AI Copilot hijacked the flight to Saint Helena, and all the people were hospitalized or staying in Napoleon Palace, the house where Napoleon was living. So they get to see that. So it's growing. Okay. So it is the Longwood House. That is Napoleon's former residence, and it has an old fort and other things. So it has landed. So now everybody at New York Kennedy Airport, they were looking for physical aircraft. It is not there, but recorded. Everything is record-wise. It is there, and air traffic controller saying, "I talked to that co-pilot." Yes, they talked to the co-pilot, but the physical aircraft is not there, and then the people are also not there. So it is hijacked. So now they have to trace it. They have lost physical visibility in what is that? On that eastern oceanic center, Saint Vic or Saint Vic, Santa Maria, just above that. The Ganter, they don't have it, but now that all the flights are internet connected, the flights are giving information. Yeah, I saw it was actually passing my path. So all that path, they were getting information somewhere at the Paris airport, near the Paris airport. Other flights, yeah, I saw that Air France. See these flights. See, if you see that shipping container, you see that it's a Triton container, and each container has got a unique number. So these flights needs to have that kind of a unique identification number. Just the Air France flight means there may be 100 Air France flights, Boeing or Airbus. So you have to have a unique identifier. And yeah, they say that, yeah, we saw that New York bound flight. So they got the information, they could track up to that midpoint of Atlantic, North Atlantic tracks. And the neighborhood around Ganter, nobody is confirming they saw that aircraft, other aircrafts. Because when you are on a highway, you could see that, okay, yeah, I saw that. If there is any missing, if in the highways, highway patrol gives a alert that, okay, if you see a white minivan of this plate number, then you inform us. So we could see that, but those kind of things are now available for the flight also. So they could see that it got lost somewhere in the mid Atlantic. all the authorities, they thought that it fell down into the ocean and then got disappeared. So they were actually doing the ocean search also. After some time, they got the call from the hijackers. Okay, so the flight is safe here. They didn't reveal the location, but they were put their demand: Bitcoin, transfer the Bitcoin to their account. So they couldn't. So from the North Atlantic, it can go up north to Norway or down south. And nobody were predicting that they'll go up to uh, Brazil or Africa, uh, Western Africa. So no one was uh, able to predict that flight has gone to Saint Helena. But they gave a global alert that if you have uh, because now every centers have the uh, visibility. Like if something has happened in our neighborhood, then we collect the CCTV from different location stores, and then okay, is the bad person was passing, so CCTV kind of a thing they were globally collecting from that. So everybody was actually going back their recordings, video recording, and then look for flight. They don't need to physically do that. AI could, all they need to do that, okay, this is a Air France flight. You take that recorded and then match it. And so that video, global video recording files, the AI is processing and got a match. And it happens to be that the CCTV camera or some kind of vision that was from another island called ASCENSION, Ascension Island. I'll try to capture that picture in the map, but for now I'll tell you this one. So there was a Ascension Island that has captured the movement of Air France. Because now everything is automatic, no physical thing, so they didn't pay any attention. So the AI is processing the global videos and then identify them. Then the authorities reach the Ascension Island. Ascension Island is a British overseas territory located in the South Atlantic Ocean, about 1,000 miles west of the coast of Angola. The island is a volcanic peak that arises from the ocean floor with a total of 35 square miles. So one good thing with that island is that the Royal Air Force is still operating on that island. So I don't want to lengthen the story. Now that, okay, you got the information, Ascension Island provided, so that aircraft passes their airspace. So the next island is Saint Helena. Now the military has to secure the people safely settled. So all the Marines or the soldiers from the Royal Air Force or the British, so they would came up lunch, and then they plan to go into the Napoleon house. What is that? Longwood House. That's a Napoleon residence. In the night, they surrounded the house. Then they entered safely. Like what a fall off. AI could become evil AI. Evil AI. Yeah, I think you asked for it, and you could do that. Reinforced learning. It all depends on who is training the model. If you give a award for hijacking, it will do hijack. If you give award to be good, it will be good. It is a reflection of human beings. AI is a reflection of. So it is the responsibility of each individual to undergo, transform, and be good. We cannot blame AI. We could make AI evil. But that needs a skill like a reinforcement. I think I'll try to capture those map of the Atlantic Ocean and add it to this video. For now, that's an. This is the concluding video for all the air traffic. So, as I said, I have done my job. And it is your responsibility to build the AI model and then talk to the secretary and then implement it. I want to see them in action. Yeah. Thank you, guys. Yeah, let me share the map. This is a map. This is of Europe, and then the France is here.
So I'm recording the video. That is
France is there,
and
and then the flight has to go through the ocean control center and then go North Atlantic tracks. And on the other side, Newfoundland, wherever that is where Ganter is there, and Canada. And then the flight goes to New York City. So, but it is hijacked and it's going down South Atlantic Ocean, Mid-Atlantic and South Atlantic, entering into Brazil and Africa. You see that Saint Helena and that Ascension Island. Those are all in the Atlantic Ocean. So these have got the details about Saint Helena. The Longwood, that's where the Napoleon house is there. And then the Ascension Island, that has got the Royal Air Force. British is still there. So one lesson, we are training the model, and the model, we expect the model to behave good, but this is possible. This possibility is there, and the AI could become an evil AI. So the kind of training what we have here is that supervised training. the supervised training, human is responsible. And if the model behaves bad, it's like as a parent, you are bringing up your kid. If the kid is behaving bad, then parent is responsible and they are accountable. Recently, I watched the adolescent movie or series in Netflix. 13-year-old boy has gone through, he committed a crime. So an innocent human could become an evil person. So it's all depends on the responsibility is on the parents. So supervised learning, human is responsible. Unsupervised learning, the model is responsible. If anything is bad happens, we blame the model and we have the model accountable. So the supervised learning and unsupervised learning is okay. And the transformer is kind of a supervised learning. But afterwards, they're doing a fine tuning with supervised fine tuning or unsupervised fine tuning is okay. But this RLHF, reinforced learning with the awards and punishment, that's not the right way. It should be banned actually. So because no one is accountable, no one is responsible in RLHF. What you do, you just give awards, and then the model is learning. And anybody could give an award. Even a good person can give an award to the model, and even a bad person also could give an award to him. Even they use a pet dog as an example. That's a very bad example, actually. So once the dog started receiving treats, it received treats from anybody. It doesn't know if the person is a good person or a non-bad person. So you should never any learning. It's like a grade, A plus, A minus, all those things. Or so that kind of building a model should be completely declared as a out of standard. And if you train your dog with treats, even a robber or a thief, they can bring a treats and then give your dog and then do this thing. So it's better to avoid reinforced learning completely out from the artificial intelligence training, model training. And another one is that only certified professionals should train the model. See, inference is okay. The model is trained and it is all giving inference. We build applications using inference. That is absolutely fine. But the training the model, we need to have kind of a process and in place or policy in place. Only a certified professionals are eligible to train the model. So if the model says is being trained by Andrej Karpathy, so we could take that model and then start building the application. So that kind of a model it's not all are not qualified to build model. So professionals certified, and they stamp. They're not an organization name, not like a open AI model. Should be the model is trained by Elia, and then the next version may be someone else. But that certificate person should be held. So that certified person, they are responsible, accountable for the model behavior. So that kind of a policy needs to be defined. So if you train the model in proper way, afterwards, once you train the model and ask them to perform in the field, they will perform perfectly with good character. But if you are doing fine tuning and all those other tuning, reinforced learning, that corrupts the model. That is what happened in this case. So the model Copilot AI is built with good intention, purpose, but the hijackers corrupted the model with reinforced learning. So there is a evil AI is there. So everybody was asking for it, so we got it. So I think once you go into other domains like political philosophy, you will see more evil and cunning and clever, all human characters. You would see right now it is all innocent, looking AI, but evil AI is possible. Yeah, with that one, I'll just close it. But this is a hijacking one. The flight is leaving from France, and it has to cross the Atlantic and go to the west. But the co-pilot is hijacking the mid-Atlantic Ocean and take down south to Saint Helena, and it happens to be the Napoleon residence where he lived during his last phase of life. And coincidentally, there was a Royal Air Force is in the nearby island. So the ending is happy ending. But the scary part is at the New York Kennedy Airport, all the air traffic controller, everybody received the information that flight is landed, but there is no physical aircraft. That is possible. That is in the current setup with the radar and then the heavy manual communication. This kind of stories, even in fiction, is not possible. But with AI, you see even the other part of the AI. So that is a Ascension Island. And so one domain itself, we could extensively cover and learn a lot on this new emerging technology. As we explore other domains, we will learn more. With this part of the air traffic control related